In this video, we're going to look at the difference between linear and exponential functions given a table. So let's look at this linear option. If we're looking at our x's, they are going up by 1. If we're looking at our y's, to get from 4 to 7, we add 3. To get from 7 to 10, we add 3. And from 10 to 13, we add 3. Now let's look at the exponential. If we look at these x values, the pattern is going up by 1. But if I'm looking at the y values, to get from 3 to 6, we have to multiply by 2. To get from 6 to 12, we multiply by 2. And from 12 to 24, we multiply by 2. So linear functions have an adding or subtracting pattern on the y's. If we're looking at exponential, the y values are going to change by multiplication and division, while the x are going up by the same constant amount. So let's look at some and decide if it's linear or exponential. So notice all of my x's are going up by 1s. So let's look here at our y's. To get from 7 to 12, 12 to 17, and 17 to 22, we're just going to keep adding 5. So that means we are going to have a linear, because linear is the add or subtract pattern. Exponential is the multiply divide pattern. Let's look at another example. If we're looking at the x's, they're all going up by 1s, and let's see how the y's are changing. 2 to 4 is times 2. 4 to 8 is also times 2. 8 to 16 is times 2. So this would be exponential because of the multiplication pattern on the y's. The next table, our x's are going up by 1s, and our y's looks like it's dividing by 4. Divide by 4. From 48 to 12, 12 to 3, divide by 4, and from 3 to 3/4, we're dividing by 4. Another way of saying this is multiplying by 1/4. So you can write this as divide by 4 or multiplying by 1/4. But because of that multiplication and division pattern, this would be an exponential function. Last example, we want to know if it's linear or exponential. So let's check out how these y values are changing. From 2 to 9, we add 7. From 9 to 16, we add 7. And from 16 to 23, add 7. So this would be linear.